Hey folks, I am Venkat. I'm a principal data cloud architect at Snowflake. I'm part of a team. We develop industry demos assets that can speak to how to solve problems and use cases, how customers can use it and offer sometimes reference framework for their journey. So in this, what we are going to go through today is processing point data cloud LiDAR dataset natively in Snowflake using the various features and functionalities of Snowflake. Um, at the big agenda, we'll go through some basic Snowflake and geospatial. I'm just going to give a brief overview of what Snowflake is, how Kato is also helping out with Snowflake. Then walk through some of the sample use cases of LiDAR in the industry sectors across. Uh, Walk through a solution, a demo, and of course, if there is any Q&A. So Snowflake, as we like to call it, is a data cloud. It's a cloud data platform. We have been in the space for almost 10 plus years. We run on top of all the major cloud providers, AWS, Azure, and GCP across the region and across the world. We have been in this space primarily being used up more for data analytics as a data lake or big data lake processing. And over the course of evolution, we have been adding more and more functionalities like you through AI, ML, applications, cybersecurity for one, and we have been also offering newer system functionalities like through Dockerized containers, which I will go through in a couple of minutes. So apart from having all these functionalities, so we had found that customers do store geospatial data sets they have been using outside. They would store natively in Snowflake, but for some of the use cases, they would have to export the data out and then process to some other systems. Exporting the data out, specifically larger data sets, is time constrained, and if they depending upon the amount of data, it could be larger. So one of the things that we started exploring and then enabling up is to bring up geospatial capabilities natively into Snowflake. So people or consumers rather can run really across large data analytics across an entire world or even across an entire country using the scalable compute nature of it. We do offer 60 plus native functions out of the box. We also can do joins. We also provide capability through our native data apps or from marketplace like with Kato to offer solutions. I'll explain on this in a short while. Two slides are there that can give you how Kato is helping us helping consumers to achieve their goals. For those there are certain boundary cases where we do not have any functions, or neither if it's not there in Kato, you can always use Python or Java, Scala libraries to do that. For example, if I want to blow up a whole string into every individual points out there, I haven't come across any functions. I had to write about a whole using Shapely functions, Shapely library to build that up. So you can offer it over there. And as of over the course of many days or many months, Kato has been offering up the H3 based solution through their analytical code box. And in conjunction with Kato, we have now built up the H3 now capability into Snowflake natively. This is not just about offering a function, but more so in how we store the data, how we access the data natively within the platform itself. That's where the benefit comes from. So this is something is coming in the private preview in the coming weeks, and hopefully it will be in the public review in the coming months. So as a platform, it is just not about storing and processing the data, but we also have a huge variety of marketplace where market data providers provide insights or showcase offer data products in our platform. Like for example, SafeGraph. They provide foot traffic data. They provide geospatial data for each and every building across, let's say in US. They have interesting use cases that works against them. Precisely is another one. Sondra, which offers some of the open source data from street maps, and of course Kato with the analytical toolbox. So more and more companies do offer data products. Another one is like location geocoding. Given in one building, it could have 3 or 4 addresses. Um, it could have 3 or 4 addresses. There are companies which Kato has one. We are trying to work with them is to say give an address and they could probably point out what is the geospatial coordinates of that, or vice versa. So if you're starting from scratch, instead of in-house building building it in-house, you could tap in through these data providers with less than 1 hour installation. You had a question.
Is there a specific format you have to publish the data to the Snowflake marketplace?
It's we have the basic geometry and geography data type, so you can store them as geography and geometry data type, that is stored up in its own optimized way, and to the customers they can query it in the way that they want. They want to see it as a GeoJSON or EWKWT or WKB. They can have access to that. So this is a high level view of how customers or consumers or customers, sorry, have been ingesting the data into Snowflake using various technology. We have streaming. We work with Kafka. We work with AWS. We work closely with all the major cloud providers. As I said, we also have a huge set of partners like with Fivetran who can get data from SQL servers or Oracle and other databases and ingest the data into Snowflake. We partnered with SafeFME and Alteryx to also migrate the data over and do the ETL processing. It's not just structured data. We can also ingest or work with unstructured data itself, like raster data file. We can work with raster data file through some of the functions. In fact, Carto has one where they have in an alpha stage where they can process, or alpha or beta stage, where they can process geospatial raster data. We have one also that we can showcase in a future session. And LiDAR data is one for one of those unstructured data too. So it's more of a data lake that the platform offers. In this slide, what you're seeing is that these are various use cases that the customers across the different industries that they are looking at adopting us, or they are looking into how geospatial capabilities can enhance. The benefit of all these use cases is that the data from various IT systems are already in the Snowflake side. There is no need to export out the data. You're utilizing the cloud functionalities or the scalability to derive insights based on the use case of needs across these industries. So, and also sometimes if you're taking something like a customer churn predictions and whatnot, there are PII informations that could be there. So because this geospatial capability is done natively in Snowflake, data governance is one thing that can be handled. Privacy is maintained because there's no leaving outside. It's all contained within the Snowflake side of things. How does Kato work with us? Kato has, as we all know, is a wonderful platform. So they sit on top of Snowflake. They interface with Snowflake. They push down all the computes into the Snowflake side to do the processing and crunching and so on and so forth, and then offer the various tiles and visualization through many of these platforms. And also recently they have been starting to work on developing up native apps like capability. These are native apps is akin to installing your app like a Spotify app on your iPhone or an iPad. You just go to the marketplace, you say I want to install this app, it will get installed in matter of minutes. It's not days, it's not months, it's just within a matter of minutes the whole app can be installed, and you can start using it as soon as it's there. Speaking about apps, this is what we did. Carto right now has a native app through Snowflake in our marketplace. Earlier there was a process where you had to do a lot of processing, installation steps to do. Right now it is just as easy as just clicking a button, and you get the analytical toolbox core functionality offered within the platform, providing functions for many of these capabilities that's highlighted over here. This was also something that is we did during our summit launch during this summer in Snowflake. We actually had a solution using Snowpark Container Service, which I'll explain in a couple of minutes, where we had taken out the fleet route optimization to run natively in Snowflake. What this helps our customers is around the route optimization capabilities, that if they have a fleet of vehicles along with vendors, they don't all of this can run. Just point out to the tables, it will go find out all the routes and what fleet truck has to go into what route, and which worker has to go and into what trucks. Carto does that, all the calculation, and offers us back as a tables natively in Snowflake side, and then on the Carto visualization you can take it and put it onto the tile set. This can run fully without needing to do external processing and whatnot. With that, I'll jump on to where I'm going with this, or what I'm trying to do a demo on this right now. So LiDAR is a remote sensing technology. It has been well known, let's say before LiDAR, it has been well known to use satellite raster data image for various various business use case, like sustainability use case and so on and so forth. But LiDAR is picking up in the field right now, and it has this, I'm not talking about like car based LiDAR data. I'm talking about like over a vast amount of land. So public organizations, or sometimes even commercial organizations, they hire with certain LiDAR data companies, where they send these planes or drones, or sometimes there are even satellites which scans the earth. So LiDAR is completely different from the raster data, in the sense that satellite raster data, you get an aggregated data set. You don't, to get the depth and all, it's a little bit hard. Whereas with LiDAR, you can actually get to the depth, like given a height of a tree, you can get to see what this floor plan is. You can, based on the light intensity and whatnot, you can find out what type of tree or what type of forestry are there. You can, it's such minute level information can be obtained. These things opens up to various amounts of use cases like these. For example, utility companies want to use LiDAR for power line inspections. What that is that they have run, the power line runs throughout the entire country, through the forest and whatnot. There is always the worry about, like, if there is a torrential storm or cyclone or wildfire, some of those things, power lines can get damaged. There is also they have to watch over sometimes the vegetation index. Vegetation, what happens is, like, these fallen trees can fall on a power line and then destroy, make an outage of the utility. So that is one example. Solar panel placement is something that I came across in the energy sector, where they want to identify which part of the regions has the best solar receptions and where they can place into it. So here was one example that was done not in Snowflake, but this was done outside, but sharing the type of use cases. Like, this was happening in New Zealand, I believe, where they were looking at different rooftops and then trying to find out which rooftop has the best intensity for solar panel placement. And of course, from a public sector, and also it's a big use case that I'm finding in insurance and whatnot. Sector is to understand the flood risk management. So based on how the flood can affect a certain property, they can evaluate your closeness to the property, how much your property value can be, or risk can be taken up. So these are some use cases that is popping up in the insurance industry, and also finance industries too. This is just a small, there are multiple more. What typically the steps it seems to be happening on the LiDAR side is that first you start off with a plane or a drone scanning up a vast amount of data that they get in, and once that data is there, it's not very clean, so it has to be cleaned and cleansed before it can be started to processing. And that data set is typically called as point cloud data set. The thing is that um, each one file can contain upwards of 1 million points. And a scan, like what you will see right now, is that it's easily you can go up to like 1 billion records to process. And that's a large amount of data processing that you need to think about. So that's where the capabilities of Snowflake as a cloud data warehouse can come and fit it in. Typically, after the data is obtained, you do the process like cleanse, normalization, feature extractions, and so on and so forth. These things can be done using the Snowflake cloud platform. And that's what because Snowflake is a cloud data platform, one of the we have unlimited compute. We can also offer unlimited storage. We run on top of S3, AWS S3, or Azure blob storage, and also GCP cloud storage. So they offer unlimited compute. We store them not as a native format. We typically store our tables in a compressed format, typically 1:5 ratio. That is, what that means is that 1 GB is stored literally as 250 MB files. So we are storing at that level of compression, so which helps in faster retrieval and processing. So we can also do ML processing natively in Snowflake. We have TensorFlow capabilities. We have PyTorch. We just added a PyCaret, and we have almost like 3,000 plus libraries, and the list keeps on growing after every month based on consumers' requests. We can do that. Filtering, projections, and all these are common to us. And geospatial, as I mentioned earlier, using those functionalities that we have recently added, those things are all natively in Snowflake. So this is an example of how Snowpark containers are running. I'll explain what Snowpark container in a meeting. I just want to give you a preview of the functions running itself. Essentially, it is a whole applications along with UI and also data processing functionalities running natively in Snowflake, which means that if you have a Docker container, for example, like with the VRP solution that we developed, all of this is natively hosted, and as you can see at the top, it's just there. You can offer UI, you can offer C++ library that is currently not possible. So this is possible by this new services that we had done called Snowpark containers. One other thing that I keep, though I mentioned Docker and whatnot, we are also having GPU-like capabilities. We have a huge partnership with NVIDIA. This allows you to do advanced ML capabilities. Where does it fit in? For example, if you're doing raster file image processing and you want to do object identification of all the rooftop of buildings, building versus park versus houses, those are large amount of ML data processing, and those operations can be offloaded to an NVIDIA-based GPU container where it can be done without extracting again the data out. So you're saving time when you're not doing these extractions. So at a high level, this is the flow. We have the LiDAR data set. These are typically LAS files or LAZ, or LAS. LAS is an uncompressed format. LAZ is a compressed format. This is a binary way of storing up the point cloud. Um, and First is that we get the data, we index the data, we try to find out what are all the different files. You'll see how much files I'm talking up. Using containers, we can extract the metadata. From the metadata we extract, we can filter on certain functionalities over here. That's what's happening over here. You'll get more perspective as I walk through some of the visualizations in the coming months. In the coming slides. Um, Once you get, you can filter it out to a very specific set of use case. Based on the use case, you can filter out to very specific areas or regions, identify those LiDAR files and process them only for the ones that is of need. The rest of the files and metadata can be stored without the need to be processing. This data is huge. So with that, let me start giving insights. So the use case that I had done for this showcase is to show is this functionality in the remote sensing world where they want to do something called as change detection. Change detection is over a period of time, how did certain area has changed, maybe after a hurricane or even over the course of period, after a new community has popped up, how much has forest has deforestation has happened and whatnot. So for this scenario, what I had to do was take the scenario of Michael hurricane over Florida. This is all the public data set I could get. From USGS, we were able to get some of these files. So these are two different LiDAR scans around Tallahassee and beyond Tallahassee itself. So I took only the Tallahassee related data records to do my processing. This is how these are files that are staged up into an S3 bucket, a blob store, and it is stored up over here. One of the thing is that when you look at these files, there are so many files of this, which you will see what the count is in the next page, is that you have no information right now that says, like, which part of Tallahassee is this image related to. Within that file, there are so many dimensions, features, or columns. What does that dimension look like? You have no information of that. So that's where we first do a step called indexing, whereby we read each of these files and then try to extract the metadata out and store them first. So now you can say now you can say that which file, what is the coordinates? Like, we also extract the coordinates. It's on this side, I think. You can say a LiDAR file. There are, as you can see, there are total amount like 2 million. What do you say? Yeah, 2 million LiDAR files containing in total internally these LiDAR files are bunch of records. Each one of those LAZ files are just bunch of records with these dimensions at the top. All these dimensions, the x and y are easting and eastings and westings. That's how they store it as in a geospatial format. Z is the height, and various other type of metrics that's needed for various different scenarios. I'm going to be using only the Z part of it. So they also store the coordinate systems. That's what you're seeing over here. Like, for example, one file over there contains like 55,000 records. If you add them up, if I had to process, that's total about like 109 billion records to process. That's a huge amount of processing. You don't want to end up processing the entirety in nature. So we have we split it out based on the data records. We found out, we split it into two data sets. One is before the event, before Michael hurricane, and after Michael hurricane. That's how we started with. Now, what is, before I go on to the change detection, where I was going into this. is first is that this is where I switch over to Kato. Sometimes I keep forgetting. So the change detection I want to see is I want to see specifically on the Florida road maps what road got submerged or damaged post event of Michael hurricane. All right. Now Tallahassee is somewhere over here. But if you take a shapefile from Florida, this is the entire shapefile of all the road maps, all the roadways across Florida. When you're trying to do these two joints across these two, you're having one side, it's a very large data set that's almost like 300,000 records or something like that versus 100,000 records over here. So you don't want to end up doing up a join or that. The very first thing you want to do is you want to filter it out to only those portions where it is of interest. Using H3 and the metadata that I showed earlier in the earlier step, I can find out of all the coverage which of those LiDARs are specifically within the roadmap. Now I have know exactly which of the 2 million records of 2 million files. I know exactly how many records that is of our interest because I filtered it out only using on that roadway map. How did I use the filter? Is using H3. Again, H3 provided from partly. I used a library, and I also, for visualization certain aspects of the time, I use Kato's H3 functionality to achieve this. So this, now that we know exactly the files to process, we can start processing. And you might be wondering, why is this road like this versus this is these yellow? Yellow is the files to process, and the pink is the roadways. Certain roadways are very long, and only up to that LiDAR scan is only within this region alone. So only these were there. These were out of line. That the roadway was so long. That's why it shows up like that. So with that capability in place, it's in a different page, but it's roughly 250,000 files that need to be processed from there. And within that, we need to extract only the H3 portion of it that lies on top of the road. Again, at an index of 9, we can extract the data out. Once we are doing that, should come up. Yep, there it is. Now we can see how the portions have changed. The darker the color, the more there is a change in the height or the Z index that has happened, versus lighter the color, there are no changes, and the yellow ones, there is literally no change over there, or in a very less change. So this is how I can do this all natively in Snowflake. Now, taking on top of this, we can put this using using DecGL. We can now put it, export the map out, and build out this as a visualization layer completely out into the world. Whereas the other one was within the platform of the Kato, this can be exposed out maybe as into your web page within your intranet and whatnot. Yep, that's it, and I'm open for question and answers.